Hello, guys. Welcome to this week's podcast. My name is Sarah. I'm a BCBA, and this is your ABA help. This week, we are going to be talking about different types of graphs. I have mixed feelings about it. We're going to get a little graphic. We are going to be talking about line graphs, bar graphs, scatter plots, what to know about them, what's important about them. Yeah. It's not too exciting this week, but it is really important. It's the foundation for us to move into taskless D. I keep kind of putting those brakes on taskless D because I really want to make sure we are ready for taskless D, that we have all the skills that we need, because it is hard. Taskless D is one. It's all about the different types of graphs and data. Taskless D is one that I see a lot of people asking for help on, like on the Facebook groups. I'll have a lot of people reach out when I'm doing like tutoring. Taskless D is a big one because it's so, there's so much memorization with it. There is so much that you don't practice in your day-to-day because like what shaping is and chaining and, all the applications, like, different types of intervention, assessment tools, things like that. But Taskless D and all the different types of graphs and data is something that we really don't use that much as a student in ABA. As you become a BCBA, there are definitely things that you should be using from that and different ways you should be approaching data collection, but it's not something you practice a lot, so taskless D is difficult. So while we are finishing up taskless D, I have 2 more podcasts that I want to do before we move into taskless D that will make moving into taskless D much easier to understand. One of them is this week, so talk about all the different basic types of graph, what you need to know, the basics of data collection and the ins and outs of the different types of graphs, how to look at them and analyze them and really make database decisions is going to come next week. It's really a skill that you're going to need to practice making decisions looking at data, especially in this field as we move to more electronic data collection methods. Our ability to look at these graphs and make decisions is so important. And these big ABA companies want so much from us to be in so many places at once. Data is going to be your best friend. Having accurate data, making decisions off of that data is really important. This week, we're going to be talking about the basics of data. And then the week after that, we're going to be talking about how to analyze those graphs, those basic data collection, displays. And then after that, we're going to move into taskless D and talk about all the different treatment designs, how that's displayed on data, how do you tell the difference from all of them. It's going to get really fun and exciting. Yeah, I know. So let's get into it. We are primarily going to go over line graphs, bar graphs, scatter plots, ratio charts, standard acceleration. There's probably some others in there, but those are going to be the primary ones that we're going to cover. We're going to talk about the ins and outs of those, what to look for, how to tell the difference, what they're used for, some examples, things like that. It's going to be great. Let's go ahead and start into what a graph is. Why do we care about them? Our classic question, why do we care? So a graph is a visual way to display the relationships between different variables and different data. It's an easy way to take a whole bunch of numbers and put them in a way that people can absorb and understand easily. Because imagine if we didn't have graphs and I gave you a week's worth of data and said, here you go, here's how this kid is doing, here's how this kid's flopping's going, or their imitation skill, gross motor imitation of clap, here's how it's going, here's the data. You would have to look at it and analyze those numbers and somehow come up with a conclusion without doing it visually. That would be really difficult. So a graph is a great way to give us a visual representation of what is happening and allows us to make database decisions off what we are seeing. There are 7 benefits that Cooper outlined specifically. I'm going to go through and list them. These aren't anything that you need to memorize. I would just be familiar and understanding why and the benefit of line graphs and also, the cons of using different graphs. I wouldn't worry about memorizing these. I would just worry about understanding the benefits of different graphs, the cons of each graph, and compare and contrast so you know the difference between all of them. I think it's important to just have that basic foundation. You don't have to go too far in depth, and I'll talk about each graph and what you need to know. So there are 7 benefits that Cooper outlines. I'm going to go ahead and read through for you guys. You don't have to memorize this. Just make sure you're comfortable and familiar with these. The first one is immediate access to visual record of participants' progress, like we kind of talked about. So you have this quick way to look and you can see their progress over time rather than me giving you a data sheet a week later. You have this immediate way to look at the data and progress. You have continual contact, allows research to explore interesting variations. So you can look at those relationships between the variables in your data, put in phase change lines and see how different things are impacting treatments. Help everyone interpret the results of a study or a treatment, so you don't have to, have your PhD in order to look at a graph and see whether something is going well or not. Obviously, to make treatment decisions, we want to have some experiences, but the average person can look at a graph and understand what's happening. Conservative method for determining significant behavior change. So it's an easy way to analyze. It's a simple way to analyze data for behavior change and make decisions based off of that. It enables independent judgment on the data. So I can look at it and make my own interpretation. You can look at it, make your own interpretation. It allows most people to have that, again, quick way to look and make their own judgments. And I can make my judgment separate from yours. It's not a, like in a study, how it has like the results section, it tells you their results, like the researchers' results from their study. A graph, you can make your own interpretations. It can provide feedback to those who are interested with the visual analysis. So whether it's you providing feedback on your own treatment or you can show the participant they have feedback on their own behavior based off the data. It facilitates communication, dissemination, and comprehension of behavior change. So again, easy, understandable. You can show it to multiple people. People can make their own interpretations. It's an easy communication method of data and behavior. That's why ABA loves it. And then also I want to make a quick note before we get into talking about line graphs. I'm going to say things like up and down line for the y-axis or, left and right or flat. I'm going to reference the axes in that way. And this isn't to insult your intelligence or to quote unquote dumb it down for you. I'm not trying to do that. For me, I know if somebody says, all right, can you put that on the y-axis or the ordinate axis, I would struggle. It would take me a minute to be like, okay, I have to visualize it and remember, okay, which axis is which. Even if you say vertical or horizontal, it takes me a second. And I want to make sure you guys have an easy way to follow this podcast and you're not getting lost in trying to apply the terms to the graph and then come back to me. So I'm just going to put it in simple terms and that will help us out. I'll put the actual term there and I'll follow it up with how you need to think of it. So that way, when you're doing your exam, you have a quick, easy way and you're not getting stuck in your head trying to remember which is where and what is what. But I just want to make that little note. It's a me thing, not a you thing. Also, in this podcast, we have so many AKAs because, line graphs and bar graphs are something that a lot of different fields use. It's not just exclusive to ABA. You guys know that. So there's so many AKAs and I'm going to list them all off for you. I would definitely make sure you learn what these AKs are because then that way you're not, you see a new term on a mock or on the exam, you're not like, oh my God, I've never heard of a frequency polygon. What the heck is that? You're going to know because you're going to learn these AKs. So just a heads up on that, there's a lot of them. Okay, our first one is line graph, aka a frequency polygon, or another aka is linear, arithmetic, or an add or subtract chart. So you've got lots there. So line graph could be referenced as in frequency polygon, a linear chart or graph, a arithmetic chart, or an add subtract chart. Got it? Cool. So a line graph is the most common graph in ABA. I'm sure you guys are very familiar with it. I'm sure you guys, use it and learned how to make them in your master's program. They're very common. You see them all the time. In ABA, each point in the graph shows a quantified form of behavior. So remember, a little trick for remembering qualified or quantified. So a little trick to remembering qualitative data. Qualitative. So a little trick to remembering qualitative data versus quantitative data is qual is an L, and remember L is for language, which is like that narrative talking. If you're writing out qualitative data, it is that narration. You're writing down what parents say about that behavior. Whereas quantitative data is going to be numbers. It's going to be taking something like a behavior and turning it into numbers and data. Because I remember that because there's an N in numbers for quantitative, so that might help you remember it. But a line graph is taking data that we are observing and turning it into quantitative data, numbers, and putting it on a graph in ABA. For all of our graphs, especially a line graph, we've got our dependent and independent variables. We're going to start with our dependent variable. Our dependent variable is going to be that vertical axis, which is the up and down one, which is the y-axis, and another AKA is the ordinate axis. So it's going to be the up and down one, vertical, that's where the dependent variable is going to go. Typically, this is going to be your measure. So this can be your behavior that you're measuring. It's going to be on that left-hand side when you're looking at a graph on a piece of paper. It's going to have a range of values for you. It's typically going to be, like let's say for behaviors, it could be from 0 to 10. It could be from 0 to 100. It could be, 0.5, 1, 1.5, 2. It all depends on your data and what you need. But it's going to be a range of values. It's going to be that dependent variable that's being impacted by treatment. So whether that behavior is going up or down, increasing, decreasing, stagnant or stable, all depends on that treatment factor. And then we have the other part of our graph, which is the independent variable. That one's going to be that flat one, horizontal line, or the x-axis. The independent variable is independent of the treatment. It's just our time measure. So over time, how is this dependent variable being impacted by the treatment? That's what you're going to have on the independent flat line. It's typically going to be like days, sessions, it could be weeks, it could be months, years, it could be whatever your data is measuring over time and what you need in order to break it up and show that. ABA, I would say, is most common by session or by day. So you have your day of data collection, you have dependent variable that is on that y-axis, independent variable is on that horizontal axis. Some AKAs you're going to want to know for independent variable are x-axis, the horizontal axis, that is also the abscissa, it's abscissa, abscissa. I always say it in my head abscus, which I know is not right because there's no stuff with nothing in that word to support it, but that's how I always read it in my head when I was studying. So I'm probably going to end up saying that again, and I'm sorry. But however you say it, it's all the same. We have the horizontal axis, the abscissa, the x-axis, and this is where you're going to kind of get your trend, your variability in data, your levels. You're going to analyze it all based on these axes. And it's important to know that most of the graphs that we're going to be looking at are going to be equal interval graphs. What this means is we have our origin, which is where the two graphs meet. So you know how you have 0 for your dependent, that up and down one, and then we have 0 for our independent, and they kind of meet and they intersect. That's going to be your origin. And then from there, from that origin where they meet, you're going to have those equal intervals that break up over time. So the intervals and the way they break up don't have to break up the same because there are two different types of measures for the dependent variable. So if you're going up by 1, you don't have to go by 1 at the bottom because it's not going to make sense because you're having two different sets of measurements. However, on that dependent variable, if you're going up by 1, 2, 3, 4, you need to continue doing that the whole way in order for it to be an equal interval graph. There is a way that you can break it if you need to jump to a higher number, but it still has to continue in the equal intervals, and same thing for the bottom. So if I were doing by sessions, I would do session 1, session 2, session 3. If I started going session 1, session 2, 3, 5, 8 without any sort of indicating on why or when those are breaking up, that wouldn't be an equal interval graph and it'd be a very misleading graph at that. But most graphs that you're going to see, especially on your data collection softwares, are going to be equal interval graphs. We're going to talk about a ratio graph next, but your typical graph, equal interval. And then also I wanted to squeeze this in here. Another way to kind of remember which line is which, because I just throw a whole bunch of words at you, a whole bunch of AKAs at you. So we have our dependent, which is the up and down, which is the y-axis. So a silly way that I remember the y-axis is like, if you are asked a question of like, why is the sky blue? And you're like, I don't know. And you're like shrugging. You like bring your arms upward and you say, I don't know why. And that's how I remember it, because you like bring your arms upward and the dependent variable is up and down. That y-axis is up and down and your arms go up and down. You say why, and that's how I remember. Guys, at this point, if you've been listening to the podcast, you know not to judge me. We all do what we do to get by. And then obviously that leaves the x-axis, the independent variable, the horizontal, the flat one, left and right one. Got to memorize those. Really important that you remember those. Remember which one is independent of the treatment and which one is dependent on the manipulating of the variables. Got to remember those basics. We'll talk a little bit more about what you really need to know about a line graph and all the intricacies of like data labeling and, all that stuff. We'll talk about that in a minute. In Cooper, it's talked a lot about what's really important for a line graph, what we need to have on it. I'm going to go through and kind of list and talk about these. You're going to know all of these. You guys are very familiar with line graphs. My best tip for this section and understanding the basics of graphing is to look at a lot of line graphs and see what is typically on them. Know what's important to have included. Get very familiar with how they're supposed to look. So when you start seeing a line graph, whether it's on the exam or out in the field in practice, that is missing some pieces, you're going to see it, you're going to know it. You don't necessarily need to recall the label and tell me what the 10 top most important things are for a line graph, but you can see something's off, and then you can use your behavioral analytical brain and figure out what's missing and how it's impacting your visual analysis. But in Cooper, what they highlight as the really important things that you need to have on a line graph are axis labels. So on the y and the x-axis, I need to tell you what the data is. So if I'm just going 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 on the left and then the bottom, but you have no idea what those numbers represent, that graph is essentially useless to us because we can't make any decisions off of it. So labels, whether that's, flopping on the dependent y-axis, and then on the bottom it says sessions. Those labels like that. And then we have our condition change lines. So this one can be a little tricky. Our condition change lines, you have our solid lines and we have our dotted lines. According to Cooper, and it varies so much, guys. Everybody, there's not hard, fast rules on what you can and can't use these lines for. The rule of thumb, though, according to Cooper here, the solid lines are going to be what you are going to use day in and day out if you just want to indicate one sort of data communication. So if you know you're going to have breaks in data or major, changes in treatment, you're going to be trying different options and you just want to report it in one line, you're going to use a solid condition phase line. If you know you're going to be reporting major changes in data and minor changes, so example of major would be a whole new medication regimen, the doctor prescribed 4 new medications to try it all at once, a whole treatment package. You're going to put in a solid line, whereas just the medication that the child's been on for 4 years gets a 5 milligram uppage and mom's not too concerned about it. That might be something you just put a dotted line on. Or a short 3-day vacation that is going to impact that child slightly, but not major disruption in therapy. That's going to be a dotted line. So if you plan on indicating those 2 different measures, you're going to use a dotted and a solid to indicate minor versus major. But if you're just going to be reporting those major breaks in data and therapy or treatment changes, solid line is going to be your BFF. And the solid line is called the condition phase change line. These are the vertical lines that go up and down. They're solid across your graph. What's important to know about these is when you put them on there, you need to have a label, what is this line doing there? Whether it's after the change line or it's above the change line, it's all fine. You just need to have a label on it. And your data before that change line needs to not connect to the data after that phase change line, because you're indicating that the treatment is changing and we need to analyze the before and after. And if you guys look at pictures of line graphs with phase change lines, you're going to see this. No biggie. It's just something to remember. But as a BCBA in practice, I highly, highly recommend putting the minor changes on your graphs, those dotted lines. Highly recommend including those events that happen. Especially, insurance runs in 6 months increments. So we do an insurance report every 6 months. You're looking back on 3-month-old, 6-month-old data, and you're trying to remember, why is there this big break? Why is there this big spike? Or what happened? I remember something happened, I can't remember. Having those dotted lines can help you be much more effective and thorough and analytical BCBA, because you can really say, this is why the treatment had, great impact or didn't, or we saw a huge increase in behavior is because this vacation happened, dad's back in the picture, or, mom unfortunately got another job and that's really affecting the child. Different things like that can really help you have explanations on your treatments. So I really recommend those. I think they're incredibly helpful, especially when you have large caseloads and you're managing lots of kids and there's a lot of variables going on. We get so much information every day. So it can be really important. And it can also be things internal too, like your clinic gets new staff, or the child's favorite therapist quits or goes on vacation for a week. Things like that too can be really helpful. Then obviously for a line graph, you're going to need data points. So you're going to have each little point of your data representation. You're going to have your line paths. So you're going to connect those dots until you either stop collecting the data on that graph or there's a condition change line. So you're going to connect all those dots, and that's going to help us interpret that data. We'll talk about that next podcast. You can have multiple data paths, and that's when we get into different treatment designs that we're going to talk about in 2 podcasts, where we get into task list D, when you have multiple data paths, different treatment approaches. There's a lot of different ways you can put your data on a line graph. Just understand the basics of it and understand and look at them. We'll talk way more about it in task list D, about what you can and can't have and when you can and can't have based on what this and that is. That's why it's so complicated, guys. There's so much. Another form of line graphs I was kind of hinting at earlier is ratio graphs. So these are going to look the exact same as line graphs. All the same rules apply except for one thing. So your x-axis that's on the bottom, the left and right one, horizontal one, that one is going to be equal intervals, your time. So 1 day, 2 days, 3 days, 4 days, whatever your measurement is. That's going to be the same on the bottom. And then your y-axis is what's going to make it a ratio chart if you chose to go this way. So think back to math class. A ratio chart is going to be where you are increasing, I don't even know the math words for it, but basically you go proportionally, you increase your measurement. So let's say we were measuring flopping and we wanted to do a ratio chart. This would be where we have our first line would be 2, and then our second line would be 4, and then our third line on our y-axis is 8, 16, 32. See how it's like increasing? It's not increasing by equal intervals. So 2, 4, 6, 8, it's going in a proportional way of 2, 4, 8, 16, 32. So that makes it a ratio chart. If you see that, that's what that is. It's not something I personally have ever used. It could be useful for reporting very large data. So like if you had a kid who had a range from 0 words spoken in one day to 1,000 words, maybe something like that might be more helpful to represent your data. Something to consider. It gets a lot more information on a line graph than an equal interval graph would. It's very important to know that these exist when you're analyzing data, because you can have a very different interpretation on a ratio graph versus if that were put on an equal interval line graph. So keep that in mind. And then another type of graph that's going to look very similar to a line graph is called a scatter plot. How you're going to identify this one? So this one is going to have those equal intervals again on the y and x axis. It's going to look like the traditional line graph, except a scatter plot, the dots are not going to be connected. On a scatter plot, you're using the temporal relations of the behavior, so that time measure, you're using that to kind of analyze your data. So let's say, like an example I've used a scatter plot in the past is for potty accidents. So I had my staff graph or, take data on, and I had graphed it on a scatter plot of every time a kid had an accident. So he was doing really well at potty training, and then suddenly something switched and he started having accidents. Instead of taking him on an hour schedule that he hated, or every 30 minutes and he just despised it, I decided, let's go ahead and be more intentional about our potty breaks. Let's do a scatter plot. Let's see when these accidents are occurring over the week. So I had them put based on the time and the data, and we discovered on the scatterplot data that every day around 11 o'clock he would have an accident, and then every day around 2 o'clock he would have an accident. We're able to take him before those accidents and decrease those accidents by giving him more opportunity to urinate when his bladder was full. This is only information that we'd be able to get on scatterplot data because it has a temporal relation of behavior. Definitely check out pictures of them, look at them, how they lay out. I think it's very interesting. They're very useful tools when you have those opportunities and you need to know when these behaviors are happening at certain times. Another good example is if you have a certain kid that just has big bursts of behaviors, you might be able to figure out what's going on. Good example is like, a kid that will start flopping and whining and crying at just like seemingly random parts of the day. You might find that there's a pattern because their medication's wearing off, or their therapist just switched, or they're really hungry. It's right before lunchtime. Every day at 11 o'clock, they just have this big meltdown. Scatterplot will tell you that information. You'll see those kind of like focus groups of data, and you'll be like, that's interesting. All right, up next we have a bar graph, aka histogram. Bar graphs are the simplest and most adaptive form of visual analysis in ABA and in general. It's a great way to summarize lots of data, lots of information. You can put multiple different sets of data, multiple variables on a bar graph. Really great for that. They're used to summarize performance under different conditions. I use them, and a lot of other BCBAs use them to visually represent our FBA data. So if you guys have ever done FAST or QABF, the questions about behavior functions, you can put those on a bar graph to represent the different behaviors and the functions, and kind of like where those behaviors are spending the most time in the different functions. I don't know the behavior analytic way to say it, guys, but it gives you a visual way to see that, okay, for this behavior, there's a lot of attention seeking based on this bar graph versus only like half of that behavior is escape. And you can look at that on a bar graph and visually analyze that. Again, look it up if you're curious. There's lots of great resources. Bar graphs can be helpful under, again, very specific circumstances. Cumulative record, what it is a cumulative, a total overview of a behavior. So cumulative record, you are adding up the behavior over time. Again, it has to be a very intentional choice that you make to use a cumulative record tool. It's where, let's say a kid is learning sight words and you want to see how many sight words over time that they're learning, and you want to be able to show them and tell families like, look, they've learned 100 sight words, they've learned 200, 300. Cumulative record can be really good for that. I used it for like on the VB map on level, I think 2. In order to get a level 2 for tacting, you need to know like 250 tacts, or maybe it's 500 tacts. I don't remember. But it's good to show that total vocabulary so you can see over time that they've learned 200 tacts. You can, target each tact individually and add it to this cumulative record and show over time their rate of learning and the response rate, or overall response rate is the actual term for it, to show how quickly they're learning, the tacting skill. Because if you think about and analyze cumulative record, the faster our data, our record is going up our line. So a cumulative record is shown in lines, or you could do it in like a bar graph, but then you would like put a line to kind of track that bar graph going up. The steeper that line is, the faster that line increases, is the more that child is learning at a quicker rate. And what this is showing, like let's say we're teaching them sight words and they are just so smart, they learn five sight words every single day. They master it 5 every day. They're golden. That would be, day 1 would be 5. Day 2 would be 10, because he had 5 yesterday and 5 new ones today, so that makes 10. Day 3, he's learned 5 more, so that makes 15. Day 4, he's learned 5 more, that makes 20. So it's going to be building up. So let's say he's such a smart cookie, he's actually really picking up on this skill, so he's learning even faster. So now he's learning 6, 7, 8 a day. So on like day 6, that would be 27 that he's learned. And then the next day he learned 8 more. And you can see how that's going to increase over time. You just keep adding it. Cumulative Record is really good at showing the treatment is effective and they're learning the skill over time. Cumulative Record, another important thing to know is that it will never, ever, ever decrease. You will not lose any data on a cumulative record. Instead, if the child's not learning any more sight words, like let's say they've plateaued because they have some sort of barrier to learning, the cumulative record is just going to be flat. It's going to be steady. There's not going to be an increase. There will not be a decrease. It will just stay at, let's say on day 4, he's at 20, and then, something significant happened and he's just not doing sight words anymore. He hates the program. It's just going to stay at 20 until he learns a new one, and it might go up to 21, or if he picks up his old rate of learning, then maybe you'll see that. When you're analyzing that cumulative record, like I said, you can have the overall response rate. You're looking at the entire history of learning. You can see how quickly they're learning skill or not. And then if you wanted to analyze a week, you'd notice that there's just huge spike. They learned so many words on this day, and you're zooming in on a few days. That's called a local response rate. So you have your overall response rate and your local response rate. Cumulative records can also be really good for feedback. So if you have somebody that needs to be training for a marathon and you can do a cumulative record of how many miles they ran, that can be a motivational tool. It can also be used to show hey, you're not running as much as you need to be or you used to be. It could be useful for that. In very specific circumstances, you're going to be using a cumulative record. Up next, we've got a semi-logarithmic chart, which is also can be a ratio chart, and a standard acceleration chart. So those are kind of AKAs. Ratio chart is its own thing, and then standard acceleration is kind of a branch of it. But in literature, sometimes they're used interchangeably. I would know that ratio charts are something that has a y-axis that is different from the x-axis and is proportionally scaled. Standard acceleration is its own beast. It uses a component of ratio charting for the way it graphs data. So standard acceleration chart, it analyzes how frequency of behavior changes over time. The standard acceleration chart came from precision teaching. So precision teaching is a whole passionate cult within ABA. It's its own field almost. There's a lot of benefits and research behind precision teaching. The BCBAs that really use and implement it are very passionate about it, so I definitely recommend looking into it if you are curious about another way to approach teaching and analyzing data. I've been to a few conferences where they talk about precision teaching, and the speakers end up jumping around in joy. It's absolutely crazy. They're very excited about their data collection, which I get excited about things too, so I don't blame them. So for precision teaching, they believe that the best approach to learning is best measured by response rate. Learning occurs through proportional change, and that past performance can project future learning. These are all kind of the standard ideas behind standard acceleration charting that's used in precision teaching. With standard acceleration charting for the exam, you don't need to learn how to do it. It's very complex, and there's a lot that you have to learn with it. It's not something you just look at and graph like a line graph. For the exam, I would just focus on understanding the basics on reading it, understanding what is a behavior increasing and decreasing on a standard acceleration chart. Looking at it, make sure you understand when you see it, this is a standard acceleration chart. Make sure you can identify the x-axis and the y-axis on it. Just the basics. Make sure you read the basics of it. That's what I would focus on. You can also, I found it helpful when I was studying to watch just a YouTube overview, just a 10-15 minute overview video on what a standard acceleration chart is, just to get the idea. Just so it's not a foreign concept, something you're fairly familiar with. I think you'll be good to go there. That's kind of the overview of the graphs that we use. I want to talk about a few things real quick, and then we're going to wrap up this podcast. In your master's program, I'm sure you learned how to make the most sick, coolest, perfect graph on Excel, or maybe they had some type of software that you used. This kind of one of those skills that is a performance trick, I find. It's an old skill. It was extremely helpful before we had all these data collection companies like Central Reach and Rethink and Catalyst and Motivity. I find that it's one that we spend way too much time on. In Cooper, it's an entire chapter, graphs and data and how to analyze it. And it's really helpful. I really think we need to spend way more time on analyzing data and making decisions. and how to like adjust treatment based on data. Like, okay, I have this data and it's telling me this, but what do I do with it? I feel like it's such a big gap in our field, and it's like the essential of being a BCBA that nobody really talks about and teaches you. So, okay, this kid's not learning imitation and the data's all over the place and I don't even know where to start. What do you do? Nobody really talks about that. But instead, your master's program is teaching you how to make this really cool line graph and making sure you make it perfect and it's gorgeous and all your like dots and everything's connected and it's black and there's like a format with it all and like there's like lines. There needs to be lines. We're spending weeks on this and I think that's crazy. So my plan is to spend this podcast talking about the graphs, and then next week we're going to really talk about how to analyze the data, what to do with that data. And I would love to create more material on what to do and like how to be a BCBA based off these like graphs and data, but we won't spend too much time on it next week. But just so you're prepared, that's kind of my reasoning on that. I know like when I became a BCBA, I was just like, okay, now what? Like, okay, I have all this knowledge, all this information. How do I like functionally apply this data? So if you're feeling lost, or if you do feel lost in the future, it's okay. It's not you. Perfect. So that is everything. That was a quick little overview, but make sure you learn everything we talked about in this podcast. I really kept it simple because, line graphs and bar graphs, they're going to get much, much more complex. So I want you guys to have a solid foundation, understand how to find that dependent variable, understand what an independent variable is. I didn't go into it too much in this podcast because I know we've all spent so much time on it in grad school and in practice. So just use what you know, apply it, practice some mock exams and information, make sure you memorize which axis is what, data labels, phase change lines, all that stuff. Different types of graphs, all those AKAs, then you got it. Cool, guys. Have a great week. I am so excited to work through task lists. We got one more task list C video and then task list D, and then we're going to get to the good stuff. We are going to get through this together, guys. Okay. Bye. Have a good week, guys.